In this video, we're going to explore much deeper into derivatives and the concept of a tangent line when it comes to derivatives. So to begin, let's say we have some graph on the xy plane. Let me just draw that real quick. And that'll be our xy plane, and say we have some function on it called f of x. And let's draw that. So we can have a nice little quartic function here called f of x. And let's say this point is x equals a. And this point over here is a comma f of a. Now let's say we want to find the instantaneous rate of change of that point, also known as the derivative. Another way to think about the derivative is the slope of the tangent line at the point x equals a. So a tangent line is any line that intersects a point at a 90-degree angle. So, well, not a point, but the function at a 90-degree angle. So if we have the tangent line that goes like this, that's not my best line, but it'll do. And it'll be intersecting f of x at this 90-degree angle. And the slope of this line is the derivative of f of x at point A. So to write that down, let's call this function m of x. So the slope of m of x equals the derivative of f of x at point A. Let's look at this problem. So it says for a particular function g, so our function will be g of x, so for any particular function g, we know that g prime of 5 equals 2 and g of 5 equals negative 3. And it wants us to write an equation for the tangent line, so the line tangent to the point, at x equals 5. So let's write down what we know so far. So we know that g prime of 5 equals 2. That means the derivative of the graph of g at x equals 5 equals 2. And we know a point on the function g of x, g of 5 equals negative 3. We know that the point 5 comma negative 3 exists on that function. And it wants us to write an equation for the tangent line. So remember how the slope of the tangent line is the same thing as the derivative. Now we know the derivative at point x equals 5 and that it's 2. So the slope of the tangent line at x equals 5 is 2. We know that because the slope of the tangent line is the same thing as the derivative at that specific point. Furthermore, we also know a point on that tangent line. Because it's asking us for the tangent line at x equals 5, we know that this tangent line must intersect the function. So let me just draw an imaginary function. It's not going to look like what they intend to be g, but it'll do. So let's say we have 5 here, and we have a negative 3 here. And this will be g. So we know that 5 comma negative 3 is a point on g of x. And since it's asking us for the tangent line that intersects this point, we know that it's also a point on that tangent line. So this point exists both on g of x and the tangent line. And that's all we need to create a linear function because a tangent line is obviously a line. So we know that m equals 2, and we have a point on that tangent line, which is 5, comma, -3. With this information, we can write a formula for the tangent line using point-slope form, which is y minus y1 equals m times x minus x1, back from algebra. So y minus -3, so that's plus 3, equals the slope, we know that to be 2 times x minus 5. If we want to simplify that even further, we'll get y equals 2x minus 10 minus 3, giving us 2x minus 13, which is the slope-intercept form of our final tangent line. In this problem, we don't know the derivatives, but we do know the function. So using that, we can find the derivative. It's still asking us for the equation of the tangent line, and we know the x-coordinate to be x equals 2. So for tangent line problems, we need two things. So the first thing you need is the slope, and the second thing you need is a point. So to find the slope, we can use our derivatives. So we know the graph of q of x to be negative x cubed minus 4x squared plus 4x plus 3. So we can determine the graph of q prime of x using our derivatives. So if we use power rule a bunch of times, we'll get negative 3x squared minus 8x plus 4. So we want everything at the point x equals 2, negative 2, sorry. So we need to find a point that is at x equals negative 2 and the slope at x equals negative 2. We have our two formulas, we have the original and we have the derivative. All that needs to be done is plugging in the point. So we'll need to find q of negative 2. So negative 2 cubed minus 4 times 4, because 2 squared, plus 4 times 2 plus 3, which will give us negative 2 cubed is negative 8, so that'll become a positive 8 minus 16 plus 8 plus 3. 8 minus 16, negative 8 plus 8, that's 0. All of this cancels out to 0, and we get 3. So we know that the point negative 2, comma 3 exists on the graph q of x. So we have our first thing, we have a point. Now to find our slope. So we have the derivative of the function. To find the particular derivative at x equals negative 2, we plug in negative 2 into the equation. So negative 3 times 4 minus 8 times negative 2 plus 4. Oh, sorry, this is wrong. This should be negative 2 here. So which will leave us with 8 minus 16 minus 8 plus 3. So it'll be negative 16 plus 3, or negative 13. Sorry about that. So it should be negative 2 comma negative 13 instead of 3. That is our point on q of x. And using the same thing here, we'll get negative 3 times 4, negative 12, minus 8 times negative 2, plus 16, plus 4. So 16 plus 4 is 20. 20 minus 12 will be 8. So we know that q prime of negative 2 equals 8. So we have our slope and we have our point, which is all we need to begin formulating the equation for the tangent line. So using point-slope form, which I'll write down just for reference, we will get an answer of y plus 13 equals 8 times the quantity x plus 2. You can leave it at that because that's a valid form, but if you want to simplify further, you can do y equals 8x plus 16 minus 13, 8x plus 3, which will be our slope-intercept form and our final answer for the tangent line of the function at x equals -2. To see that in a graphical representation, I've graphed our function here, our tangent line that we came up with, and the point that we found. And as you can see, the red line is the function, and this is the tangent line that intersects this function at point P, which is -2, -13, and the slope of the slope of the tangent line at point P, which is 8, is also the derivative. So if we do our derivative function, so q prime of x, oh, it graphs it for us. So if we do q prime of -2, x equals 8, which is the same thing as the slope of our tangent line right here. And we use the point to find the y-intercept and solve for the function in point-slope form as well as y-intercept form.